Welcome back to Coding the Sounds of Music. In this video, we will do Challenge 5 and we will learn about the tone or frequency of the notes that we've been learning about in the past several videos. Take a moment now to pause your video and navigate to page 3.1, Challenge 5 Background. Resume your video and we'll get started listening to notes. Have you ever listened to an orchestra tuning their instruments before a concert? Or perhaps you've heard band members tune their instruments before a jam? How do the musicians know the frequency for the various tones for each of the strings of their instruments? Where do those tones come from? There is an accepted scale that has the frequency of all the different notes that can be used in Western music. Now, there are other scales used by other parts of the world, but most music that we're familiar with is written using this scale. For example, the piano is tuned to the Western music scale, and there are 88 keys on the piano, and every one of those keys plays a different note, and that note has a particular frequency tuned to it. How do people know those frequencies? Well, that's kind of a complicated question, but if you're interested, you can scroll down and take a look at this fancy equation. This mathematical equation is based upon some very fascinating physics and physiology of the human ear. And so this equation is where the frequencies for the different notes come from. Let's navigate to the next page. Control, click-pad to the right. Musical notes on the C major scale are composed of 7 notes, A through G, that repeat every 8 notes on the piano keyboard. These 8 notes in a grouping are called an octave, and the frequency within an octave doubles each time. Different notes within an octave are represented through letters, and the same note among octaves is represented with a number. So, for example, C2 has a frequency of 65 Hertz, while D2, that's in the same octave, has a frequency of 73 Hertz. Contrast that with C4. It has the same letter, C, but it's in the 4th octave, and it has a frequency of 262 Hertz. So notes are representing different frequencies based upon their letter and the number. The letter represents the note within the octave, and the number represents the octave. On the next page, we will practice using these different designations with a new Python command, and that is note. We're going to use the note method to actually send the note over to the hub instead of the frequency. So now we're going to transition from the idea of frequency and vibrations of sound to notes and music. So musicians think in terms of notes, but underlying that is the physics of the frequency of vibration. Let's go to the next page, Control, arrow to the right, and here is Challenge 5. We're tasked with using the method sound.note to play a note, that is something like C4, for a period of time. And we're going to do a whole note of C4 at 100 beats per minute. Conveniently, you've been provided with the time duration for a whole note at 100 beats per minute. But remember, we know how to do that. We did it back a few challenges ago. But now we're trying to learn about notes, so we don't need to worry about that calculation. So we're going to play C4 at 100 beats per minute, and then we're going to try changing it to C5, and we're going to see if we can hear a difference. Once we do that, I'm going to ask you to go back and edit and try to contrast D4 and C4. Let's navigate to the next page, Control, ClickPad to the right. My hub has already been imported, so I'll click down once to go to the next line. And now I'm going to add my new method. Menu, Hub, Built-in Devices, Sound. Now here it's different. I've been using tone with frequency, but now I'm going to use note with the note and the time. So 2. It shows an example of how the note is entered. I need to enter C4. So to do that, I need to do a capital, so Shift, and the letter C, and then the number 4 for the octave. I'll press Tab, and I was given the time interval of 2.4 seconds. That's a whole note at 100 beats per minute. So I'll put in 2.4, and I'll go to click once to get out of my parentheses and enter to go to the next line. Let's listen to this, but first let me grab my hub and bring it up to the microphone, and then I'll press Control and the letter R. Again, Control, letter R. Great. Let's contrast this now with C5. To do that, I'm going to go back one page, Control, ClickPad to the left, and I'm going to use my ClickPad to negotiate my cursor to the number 4, that's the 4th octave, and I'm going to press Delete, and I'm going to put in the number 5, and that'll be exactly 1 octave higher. Remember me telling you this is twice the frequency? So whenever you change an octave number like this, you actually double the frequency. But these are notes, and these notes have meaning in the C major music scale. Well, let's play C5 and try to remember what C4 sounded like. Control R. And again, Control R. Well, great. Now I'm going to leave it to you to edit this document on the previous page, to return, Control, click to the left, and I want you to change this and explore other notes, but remember the challenge was to explore how does C4 compare to D4. We looked at C4 and C5, that's the same note in a different octave. What I want you to do is to contrast two notes that are different in the same octave. D4 is just after C5. So take a moment and explore playing different notes and try to understand the difference between the letters and the numbers. That is the note A through G and the octaves 1 through 8. So pause your video now and complete the challenge, then resume the video and we'll wrap up this video. Well, I hope you got your program finished. Did you hear the difference between two notes that are the same letter but different octaves? Also, Did you notice the difference between two notes that are in the same octave but with different letters? So now you've learned a lot about music. You've learned about the frequencies of different notes and the C major scale. You have also learned how long a note lasts, depending upon if it's a quarter, half, or whole. So we're getting very close to our goal of being able to write the music for Twinkle. Stay tuned for our next video. I'll see you there.